Okay, so in our previous session, we talked some kind of theoretical information regarding about linear regression. Is it correct? Is it right or not? So within that machine learning, within that linear regression, and so we would like to go for finding the best parameter, right? For that one, we are using the least square method to finding the coefficient values and the constant, I mean the intercept values, right? Okay, now, and we've seen that a lot of assumptions, if you want to performing the, or if you want to apply the linear regression, whether your model is correct or not, based upon assumptions, and we have to check multiple assumptions, and if all assumptions are passed, then maybe the model what we are getting, that it could be the better result. Okay, and for validation of your model, then we have we use like a lot of matrices, right? R square, adjust R square, mean square error, root mean square error, and mean absolute error. Okay, and AAC and BAC and predictive prediction power, different other stuff we see in it our previous session. Is it correct or not? Regarding about that one, I'll share the document, and our previous class lecture recording also I already uploaded in our LMS. So let me see how many people are access that recordings or not. Let's see now. Okay, so people, only one invitation has not accepted. Ashif Ahmad, you are the only one guy, you're not accepted that invitation. Can you please check your mail ID?
Yeah, I got the email. I'll accept it.
Yeah, please accept that one and set your own password, and you would like to go for access that recordings actually. Okay. And okay, so now let's go for the multiple linear regression. Let's go for multiple linear regression. So so previously we just seen only linear regression, right? Multiple linear regression in the sense we would like to go for, you might having that multiple independent variables and one single dependent variable. Block, and within that one multiple linear regression, let's talk about multiple linear regression. Linear regression and multiple linear regression both are same, there is no difference. Okay, the only difference is that in multiple linear regression, which is extension of the simple linear regression, okay, that allows the more one or more independent variables. Okay, so when we can apply the simple linear regression and when we can apply the both are in perspective, by the time of implementation it could be the same, but the difference in a theoretically or for understanding purpose. Okay, this is my data set. If the data set which is having only one independent variable, one dependent variable, then which means that it will be go for the simple linear regression. Okay, for example, if I have a data set, the data set I have the multiple independent variables x1 and x2 and x3 and x4, here y. So this y which is depending on the x4, x3, x2 and x1. Okay, here these are the four are the input variables or independent variables. Okay, so if the data set it might be containing the multiple independent variables, then it could be the equation for the multiple linear regression is y means your response variable. Y here b naught is the coefficient. Okay, b1 is the coefficient of x1 and b2 x2 and so on. If we have the n input variables are there or n independent variables are there, for each and every coefficient you each and every variable or each and every independent variable, it should having the some kind of coefficient. Okay, your x1, x2, x3 are the independent variable, and b1, b2, b3 are the coefficients of this particular values. Okay, our goal is that we should go for finding the best values. Okay, b0, b1, b2, b3 and so on. You should go for finding the coefficient values. So how you can able to go for finding the best values? So we would like to go for minimizing the difference between, see for example, this is your actual data. Okay, after you are creating this equation, if you are substituted these values, you will be getting some predicted values. Okay, this predicted value and this actual value, the difference we are calling it say residuals, or else we can call it say errors. Okay, our aim is that we need to go for reduce the error, actually minimizing the difference between predicted values and actual values. Correct or not? Clear? So for that one, we have a lot of cost functions or error functions. We have it from that one. The first from that one, MSC. MSC means what? Mean square error. So you might use the mean square error, or else we can use the root mean square error, or else we can use the mean absolute error. Okay. So different matrices we can use it. Those are the common matrices for no giving the difference between the or loss function. If you want to get the loss value, then we can able to go for using the any one of the method here. Okay, to determining the best fit line, that means if you are plotting that x values, okay, and values, you will be getting the line, right? This is the line we are calling it's a linear line. To get this particular linear line, a best fit line, then we can use the least square method. This is the thing already explained in our previous session. Even it is a multiple linear regression also, we are going to be using the least square method only. Okay, so here this b1, b2 and these are all the equation, these are the vector actually. Okay, these are the vectors. So you can able to go for calculating that b1, b2, b3, you can able to calculate it with the equation of this one. Okay, this is the equation. The equation is what? X transpose of x, x transpose into x. Okay, and inverse of this one, and it could be multiplied with x transpose y. Okay, here x and here x, so here x is your coefficients, your values of x, your data set actually. Okay, so y we can able to representing the your y1, y2 and y3 values. Okay, so for example, if I'm considering the data set, that data set, it is having the x1, this is x2, x3 and this is y, right? So this is x11, this is x12, this is x13, this is y1. Okay, this is uh, x, you can consider 2 1 and this is 3 1. Yes, 1 2 and this is 2 2, this is 3 2, this is y2, and this one is x 1 3, y 2 3. Okay, y 3 3, this sorry x 1 3, x 2 3, x 3 3, it's y3 actually. This is the way you have a data something like this. Okay, so this is the column, this is the one vector. Okay, this is one column, we are considering the y, we are representing with y. So this is the values, right? This is like something like x11 or x12, x13 and x21, x22, x23 and x31, x32 and x33, something like it is a matrices or matrix or not. This is like a matrix, right? So this is the matrix, we are calling it a x actually. Okay, we are representing, when it is the simple linear regression, we are not getting this all kind of things, you just getting the y equal to mx plus b only. But this is the x is a one value and this is y is a one value. But when it comes to the multiple linear regression, because of the multiple values, so that it can be matrix actually instead of the vector. Okay, so this is the b values, like so y equal to, let me consider b x plus no constant, some error. So this is the b, we are representing the, so y is nothing but it's a y1, this is the equation. Okay, y0, y1, and y3 and y4, something like this. Okay, the b we can represent it the b0, b1, b2, b3 and so on. Next, here we have, here we have x, right? So x11, x12, so this is the basically internal, it's a matrix. Okay, x is here matrix, y is one matrix, and here b is also one matrix. So our aim is that we need to go for finding the b matrix or b vector, okay, with help of the x vector and x matrix and y vector. Okay, here x is the matrix of independent variables, y is the vector of the dependent variable, and t means it's the transpose of the matrix. Okay, so we can represent it this equation x transpose, it can be multiplied with x, and the result we should do that inverse, and you should be multiply with x transpose and y. Okay, x transpose into y. So this is the formula, this is the formula will help you to finding the best b values. Okay, clear? So once if you're finding the b values, then it's a fair enough. Okay, so let's say here we have some example. For example, we can say we want to model the relationship between the price of the house and its size of number of bedrooms and location, and our data might look like this actually. So this is size of that particular house, this is one variable, and number of bedrooms in that particular, okay, house actually, and which location which is located, and the price of that one. So our aim is that I would like to go for finding the price of the house. I would like to go for finding the house price. Okay, this is my dependent variable. So the price which is depending on the location or not, by default. Okay, the price which is depending on the number of bedrooms or not, and the size which is depending on the, okay, the size of that particular house or not. Okay, these are the parameters, these are the variables, it's a predictor variables, these are the independent variables. Okay, here the price which is depending on the multiple variables. Okay, see, the first coefficient we are considering the one only. By default, we can consider the first value. It could be the one. Okay, x0. We don't have x0, so that I'm considering the one. Okay, this is x1. This is x1. This is x2. This is x3. Okay, x0. We don't have any x0, so that every time which is one. This is x0, this is x1, this is x2, this is x3, this is x0, this is x2, this is x3, and this is x4. So we don't have x0, so that we are giving that bias, it could be the 1. Okay, so this is the size is x1, this is the value, and this is the location. Okay, this is the way you should make it to the vector. We should make the matrix x. Once if you are creating the matrix x, then we would like to go for y vector. So y vector which is having the 300 to 3 lakhs, 2 lakhs 50 and 3 lakhs 50. This is your y vector. Okay, you know the text data, and you know the text data, and you know that y data. Yes or no? If you know the text data and if you know that y data, what you should do? You can easily calculate the b, right? So if you want to know that, you should know the matrices, how we can do the transpose and how we can do that okay, inverse. For example, transpose in the sense columns can be converting into rows. For example, this is a0, this is a1, and this is a2. Okay, for example, b0, b1 and b2. Let me consider this is my one matrix. Okay, a, and I want to do that a transpose. When I do that a transpose, the rows are converting into columns. So a0, a1 and a2, and this row, it can be converted as a second column. Okay, second row, it could be second column, b0, b1 and b2. This is the way we can do the transpose. Okay, clear or not? So
Yeah.
if you want to know that, you should refer your matrices, matrix concepts like no transpose, inverse, determinants, those things we can refer yourself if you have already knowledge in mathematics. So sometimes with this linear regression, when your dependent variable which is depending on the multiple variables, and it could some kind of relation, right? So it is worth nothing that, okay, noting that multiple linear regression regression assumes linearity between the independent variables and dependent variables, and also assumes the no or little multicollinearity among the independent variables. If and only if it is satisfying the assumption, then only your linear regression can be applicable. Okay, some situation as a simple linear regression, it is possible to extend the multiple linear regression, and sometimes handle the non-linear relationship using the techniques polynomial regression and regularization. Okay, sometimes your dependent variable, it is not linearity with your independent variables. That situation we can go ahead with the another regression techniques like polynomial linear regression, and we should go for apply the regularization techniques. Clear? So this is the simple information regarding about multiple linear regression. For more understanding of this one, now what I should do, actually I would like to go for the do a small project, end-to-end project on the multiple linear regression. So this is a pretty important project actually, so try to be followed. If you're not aware of the Python knowledge, you don't worry, this concepts, it could be easy to understandable. Okay, let's go for my drive. Okay, so here medical insurance. So here we have some kind of insurance data set, we have it. Let's go for open that one, what exactly which is. You just see this data set. Here we have the some features, we have it: age and gender and body mass and children and smoker and region and charges. Okay, so here I would like to go for finding the billing of medical insurance. Okay, so let's go for, this is the data set which is available in my Google Drive. So I would like to open my Jupyter notebook. So here we need to build the linear regression model. Okay, our aim is that what? Our aim is that we need to build the linear regression model for the medical cost data set. The data set which is containing the some parameters. The parameters are age, gender and body mass index, children, smoker and region feature, which are the independent variables. What are the variables we have? These are the features, independent features. Okay, so features which are the independent features or variables. Okay, and charge is the last variable. Okay, the charge is the independent feature. You can call it as the variable or else we can call it as a feature. Okay, we will predict the individual medical cost billed by health insurance. So with help of that data, we would like to go for predicting the individual medical cost billed by the health insurance team. Okay, so here charge is your dependent variable and rest of the things we are considering the independent variable. When we have this kind of data set, when we have this kind of problem statement, when we have a related regression based concept, so ultimately we should start with the linear regression only. Okay, so we need to, let's build the linear regression model. So you already know that linear regression is the supervised learning algorithm, right? Here we should use the target variable, and the target variable we have, the name is dependent variable. When the target variable or else dependent variable, if it is a continuous real number, we would like to go for apply the supervisor machine learning only. Okay, it establishes the relationship between dependent variable y, here the dependent variable is a y, and one or more independent variable that we can represent it with x, and we need to go for fit the best fit line. Okay, it works the principle of ordinary least square method, we are calling it say OLSA method, and mean square error. Okay, so these are the two things are very very helpful to, with help of this one only we would like to go for finding the best fit line. In statistics, OLSA is the method to estimating the unknown parameters of a linear regression function. Unknown parameters means what? When you're, these are the unknown parameters. Here theta 0 and theta 1, or theta 0, theta 1, theta 2, theta j. These are all these are the unknown parameters. Okay, I would like to go for finding the unknown parameters in a linear regression function. Okay, it is the goal is to minimizing the sum square difference between the observed and observed dependent variable and given data set those predicted by the linear regression function. So whatever the dependent variable initial actual charges, and after you predicting the charges, so you have to minimize that particular distance ultimately, which is going through this two concept only, minimizing the mean square error. That's it. How we are going to be minimizing it? With the help of the least square method. Okay, so here hypothesis representation, whatever our previous mathematical, I mean, when I'm explaining this theoretical part, okay, we would like to represent the equation, right? That equation we can represent it with this particular format also. This kind of function we are calling it a hypothesis representation. Y equal to mx plus c. The same thing we are representing the x theta of x, h theta of x equal to theta 0 plus theta 1 x. Here theta 0 is the constant or intercept, and theta is 1 is the coefficient. Okay, we will use the xi, which is denoting the independent variable, and yi is the denoted the dependent variable. Okay, when you pair of xi and yi is called the training example. So training example in the sense whatever the data set we have it, that data set we should use to train your machine learning algorithm, that we are calling it say training data. Okay, so the subscript I is the notation, is a simple index in the training data set. For example, the data set which is having the index 0, index 1, index 2, index 3, right? That we are representing with I. Okay, we have m training example. For example, we have the n samples or m samples, so which means that there are m training examples we have it. With the help of this m samplings or m variables, okay, so m features, we would like to go for observations, we would like to go for train your model. Okay, the goal of supervised learning is the learn hypothesis function. So h indicating that it's a hypothesis function. The same thing we can represent it with y also. Okay, and for given training set, that it can be used to estimating the y base, estimating the y based on the x. Okay, so after your with help of this one, we would like to estimate the y values based on your x values. Okay, so the hypothesis function we can represent it with this equation. So here theta 1 theta are the parameter of the hypothesis when it is the simple linear regression. Okay, for simple linear regression, y equal to mx plus c, right? The same thing we are representing with the h format. Okay, for multiple linear regression, you might have the n or m, okay, features we have it, okay, or independent variables we have it, that we can represent it with xij format. Okay, so here each and every value of xi, okay, you would like each and every x variable, it might having some kind of coefficient. So this is the theta 0 theta 1. Previously we are representing with b0 b1 b2 b3, right? The same thing we are represented with theta 0. Here it is the beta. I explaining it theoretical, it's a beta, but most of the people they are using something like, you know, this particular function format only. Okay, this function and this function both are same, just naming convention is different. Here theta 0, theta 1 and so on, theta n are the parameters of hypothesis, and m is the number of training samples, and n is the number of independent variables. How many number of independent variables we have it, that we can represent it with n. Okay, yes. So what I should do actually, if you want to do any linear if you want to do any machine learning algorithm in Python programming language, we should have some kind of libraries. The libraries are pandas, numpy, matplotlib, and seaborn. Till here, this numpy and pandas, it can help you for data manipulation purpose. But matplotlib and seaborn, these two things, it can help you for visualization purpose. Okay, and this is the thing why I'm using, actually I'm using the Google Drive, right? Inside of the Google Drive I have this particular file. Okay, this is a collab. If you want to interact with this Google Drive, then we should import this library. This is the Python library, google.collab library. This we should import. By the time of importing, we are going to be importing the drive. Okay, this is the method, or else this is the library from the google.collab package, we have the drive module is there that we are going to be importing it. Okay, and if you want to access the if you want to access this, okay, CSV file from this library, we should mount it. So drive dot mount, when I mount uh, slash content slash drive, when I'm using this, when I'm executing this one, okay, it will ask you, it will, the program, it will ask you to access your Google Drive. Okay, so these are the plot, whatever the figure you want to be displayed on the top of it. Okay, so make sure that it might having some kind of settings, right? This is the figure size and font size and weight and white grid, so something, these are the styles and parameters we are setting by the time of visualization. Okay, so if
I just have a question here. So that visualization parameters, whatever you're giving, that is for the future any plotting we're going to do. Is
yes,
that what it
absolutely
is?
correct. Absolutely correct. In future, if you're plotting something, it will go. It will give you some kind of
Oh,
specific size, right? So that
okay,
size we are giving in a initially only. Okay, and
got it.
figure
Okay,
size and so what is the font size we are using when you are displaying something on a graph? What could be the font size we should maintain, and whether it is a bold or not? So that everything we are giving some kind of settings. Without these things, also your it will show you graphs. Okay, but it
okay,
could be, if you're
and
using this kind of things, then it will be showing, you know, a little bit of proper way.
okay, and then the content slash drive. So
This
that's
is the
you're
thing.
giving
It will be
because you're
mount.
using it
It
from
will.
Google Drive.
Yes, it will mount your Google Drive. Let me execute
Okay,
so
but
that
if I
will.
have it in my desktop, then
You
that
don't
would
need
be
it.
a different.
You don't need it.
Okay,
I'm using Google Drive, so my files, because of my, I'm using the MacBook and it was having the less storage. Okay, so if I'm everything, if I'm holding into my MacBook only, then it was a lot of, you know, space occupying, and because of it's a data sets and
okay,
recordings and a lot of
got it.
stuff is there, so that I'm using Google Drive. Okay, I'm storing everything into the one Google Drive. Okay, Google Drive is nothing but it's one of the cloud only, right? Okay, in real time also, if you're
Yeah.
using AWS, so you should go for using the S3. Meanwhile, Google Drive is the one of the platform to store some information. So I'm storing everything in my Google Drive and I'm mounting from this Google Colab. Okay. So if I'm executing this one, it will ask you to mount which Google Drive should I mount. So wherever your Google Drive, wherever your files are there, that you should mount with that specific Gmail account. This
And can you just show me how did you get this
I'm
path
I'm
from
I'm
your drive?
executing. I'm
Oh, okay,
executing.
okay,
I'm executing. It was running, right. To all libraries are. It was importing into your program. It was rotating, which indicating that it's a running actually. Okay. So if it is running, yes, it will ask you some kind of permission, something like that. Permit this notebook to access your Google Drive files. Yes. If you no need, then you can say no thanks. If you want to connect, then simply click on connect to Google Drive. When you click on the Google Drive connection, it will ask you which thing we want to be connect. So this is my, okay, Gmail account. I'm just giving access for that one, and go ahead and allow. Now I can able to access. Otherwise, we can't access this file. Okay, see, it was showing me like mounted at this content, right? It was displaying this thing, which indicating that you can able to mount your Google Drive now. Okay, now inside of my Google Drive, this is the path, my drive, and this is another inside of my drive folder. We have the Mac hyphen engine and ML and medical insurance. This is the path. Okay, this is the path we should mention over here. Okay, so drive is the, make sure that first thing it could be the drive. Okay, my drive. So here we have the my drive only, right? My drive and Maganjan and ML, and so this is the medical insurance charge prediction. Okay, this is the charge prediction. Okay, this is the library. Oh, this is the folder. This is the folder I'm giving as a path. Okay, so I'm creating one variable. I'm creating one variable, path variable, and which is holding the path where we have this CSV file. This is the CSV file which is there inside of this location only. So that this is the path I mentioned over here. Okay, and so if you want to access this file, and you should concatenate it with this CSV file. Okay, that's the reason path plus CSV. If I'm giving, then you're reading the content of this particular CSV. Okay, the insurance CSV, which is having some kind of data, the data we are reading with help of the pandas function. The PD, in the sense you're renaming the pandas as the PD. Okay, so when you are renaming the pandas as the PD, and inside of the pandas, what are the functions are there, we can access with help of the PD only. PD dot read CSV, and you're reading the insurance, and we are holding into one variable, and usually we are represented with the DF. Okay, and I would like to go for showing the number of rows and number of columns in the data set. If I want to know that, we can use the df dot shape. That means here df, in the sense it's our data frame. Okay, the data frame dot shape, if I mention, then it will be display that how many number of columns we have it and how many number of rows we have it. Okay, see, so 1338 records we have it, 1338 observation, 1338 rows we have it, and 7 columns are there. So when I'm using the head function, so this head function, it will display the first 5 records. Okay, this is record 1, record 2, record 3, record 4, and record 5. Okay, out of the 1338 records, we are just displaying only 5 records because of the head function. For example, if you want to access the 10 records, then you just simply give it a def data frame dot head. Okay, and followed by the some number. By default, it could be the 5. You can mention whatever, how many number of records if you want to be accessed, then you should, right, you just give the some specific number. Just to understanding that what is the type of data here, and just for looking and try to be understand purpose, I'm displaying the data over here. Okay, and now this you are able to go for, this is your multiple linear regression equation, right? Now I
Can
would like,
you talk about when you pick pandas versus NumPy? What are the scenarios? What are the other options in case,
we
why
have
do you
only
pick
two
pandas in
functions,
this case?
we have only two libraries, numpy and pandas. Okay, so numpy, why we are using, before we are applying the machine learning algorithm on your data, make sure that the data, it should be matrices format or n dimensional array format. Okay, the data structure of the numpy, it could be the nd array, so that the machine learning algorithms can be understood. Clear or not? So for that one, we are going to be using the numpy, and I already told you, right, when you are doing, by calculation of this thing, we are doing some kind of transposition and inverse things which are available inside of the numpy only. Okay, but you don't need to do it. By the reason is that when you are implementing the scikit-learn, or when you are using the function of linear regression, automatically internally those things only will be happen. When we have numpy, if we are imported, then only the scikit-learn can work in a proper way. Okay, and now, so when we should use the pandas, in the sense, for example, if we have a data in your local or else somewhere else, if you want to access, then if you want to access the CSV files, if you want to access the Excel files, text files, PDF files, whatever it is. Okay, if you want to be access the data, then we can able to go for using the pandas. After that one, maybe if we have some kind of missing data is there, to handle it, we can use the pandas. Okay, and that's what I'm trying to be explain it actually. Okay, before we are applying the machine learning, before we are applying the machine learning, for data manipulation purpose, we are using the pandas and numpy. For data visualization purpose, we are going to be using the matplotlib and seaborn, right? You already know that. For example, if you are using the Excel, then first step is what we can do, is there any kind of missing data, and you can able to go for handle that particular missing data, right? Those are all things we can do with the help of the pandas only. Okay, so this project, before we are applying the machine learning algorithm, we would like to look this all things. So the first function of the pandas is, it's a read underscore CSV. It will help you to read the data from where you want it. Okay, and this is your multiple linear this is my multiple linear equation, right? So I would like to go for interrupt the multiple linear equation with help of this specific columns. So this is x1, x2, x3, x4, x5, x6, and this is y. This is my y. Okay, so we have x1, x2, x3, x4, x5, x6, but this is x values, right? But we don't have a theta values. Okay, the theta values we should find. That's the reason theta 0 plus theta 1 into age plus theta 2 into gender and theta 3 into body mass input index and theta 4 into children theta 5 into smoker, theta 6 into region, and h theta of xi indicating that it's your hypothesis, that means your predicted things. Okay, when if I'm considering the I equal to 1, I equal to 1 in the sense what? I equal to 1 in the sense the index is 1. If the index is 1, what could be the values we have it? Age value is the 19 and gender value is the female and body mass input index is 27.90. This is the values only we are going to be interpreting. If I'm considering the I equal to 1, if I'm considering the I equal to 2 and I equal to 3, this is the equation we would like to go for generated. From this one, what I'm doing actually, we can creating the matrices format. Okay, so this is your theta 0 theta matrix, theta 0 theta 1 theta 2 and so on. This is y matrix, y1 y2 y3 and so on, m and m command, and this the entire thing. So you are converting this and x, this is matrix of x. This is the matrix of x, right? So that everything we can representing with a simple equation, vectorization function format. Okay, x theta of x equal to x into theta. So this is the equation we are interpreted with the help of this particular data values. Okay, now, so I would like to go for understanding the data. If I look this data, we can't understand, right, in a simple manner. So that we would like to go for do some kind of visualization. Okay, and is there any kind of relationship between the independent variables and dependent variables? Here my dependent variable is, it's your charges. Okay, that's the reason I'm taking the y is my charges and x is your body mass input. You're taking only one independent variable. Okay, and you're giving the x data and you're giving the y data and you're giving the data from this particular data frame and we are giving the height of this particular figure. Okay, and you're displaying the x label in the sense this left side, this bottom side we have it, right, body mass index kg for m square as independent variable, this indicating the x label. I want to display in the y table, we can use the y label. Actually in a y label, if you want to display anything, we can use the y label. In the title, if you want to display anything on the title format, in a title we can use the plotter.title. Okay, so this is the way you're going to be plotting the linear linear plot. Okay, so this is the line we have it, right, this blue color line we have it, right, this is the linear plot. And the meanwhile, these are the points, corresponding data points. This is the data points of the charges corresponding body mass input or body mass index. Okay, and this is the line, it's a linear line actually. Okay, see, by looking this data, there could be some kind of linearity between the body mass index and charges, right? If the body mass index is increases, okay, there could be your charges also can be increases, right? There could be some kind of the above plot, we can fit the regression line into the variables, just a one normal line. And after you are finding this x and x theta, I would like to go for finding the cost function, right? Our aim is that we have to reduce the cost value, minimizing the cost function. Okay, so cost function, it will measure the how much error in your model in terms of ability to estimating the relationship between x and y. So we can measure the accuracy of our hypothesis function by using the cost function only. So cost function means what? It's a mean square error. Okay, this is the y, this y hat is nothing but it's a predicted, yi is nothing but it's actual. Okay, it is a square term. So this is, we have m sample, that is mean. So mean square error, so the mean square error only we are calling it's a cost function. The same thing we are representing with the hypothesis function, y hat or else h theta of x, both are same only, there is no difference. So this is the x we are representing. And so if you are if you want to minimize this one, we have to do the derivative. Okay, so if you want to know, if you want to find out this theta values, we have to derivative the with help of we have to derivate this cost function, then you will be getting the theta, because of theta is a slope, right? Derivation is nothing but it's slope in a mathematical notation. Okay, finally The theta we can representing. This is the function I already show you, right? This is your theta. Or else,
Excuse me, sir.
yes.
These all numerical operations conducted by this NumPy library, by using NumPy library.
Backend it was connected. Backend it was the functions are working backend. When backend in
So no need to
no need to learn. No need to
Oh.
learn, but you should know this particular formulas, at least this formula. Okay, this is the theta formula. Theta means what? It's a coefficient function. But how you're getting this one in the sense, this is the maths behind this one. Okay.
Okay, this is automatically done by the NumPy
This is
library.
automatic. This is automatically done by the scikit-learn, not NumPy. NumPy is doing these operations. Automatically it will done, but if you want to get the theta values, make sure that scikit-learn we should use it. Okay. Yep. Anyway, this is your theta. Theta is nothing but your coefficients. If you want to finding the best coefficients, then we can use this particular formula only. Okay. But you just remember this formula. No need to remember this entire equation, how you're getting this one. You don't need to do actually. So cost function, cost means loss function, error function. So what is the function? This is the method you should remember. Okay. Mean square error. Okay. This is your hypothesis function. Just remember this particular formulas. No need to by heart this entire thing. Okay. Okay. So I would like to go for checking in our data set, is there any kind of missing data we have it. Okay, for that one we would like to go for okay, this is the describe function, will help you giving that mean, standard deviation and first quartile, second quartile, everything we can providing in a describe function itself. If it is the numerical, then it will be providing it. If it is not numerical, then it cannot be providing that mean, max, these things. Now I would like to go for finding the, is there any kind of null values are there. If we have null values, it will be displaying in the some kind of ticks, okay, or else heat map. So unfortunately in our data we don't have any kind of by luck we don't have any kind of null values. So that df, this is pandas function, is null is the pandas function. Df means your data is null, is there any kind of null is there, it can be written it. Okay, and if we have anything, it will be displaying that your missing values, where it is missing and how many missing data we have it, everything you can able to display. But unfortunately here by luck we don't have any kind of missing data. Okay, there is no missing data in our data set. Now, so this is the correlation map, it will give you. So I already told you some kind of assumptions, right? What is the use of the correlation? To give the relationship between the linearity between the independent variable and dependent variable, right? So here charges is my dependent variable, children and body mass and index and age, it's my independent variable. So the charge is depending the on age, which is 0.3, the charge which is depending on the body mass input 0.22, the charges which is not depending on the 0.08. okay, so which are giving some values. If it is the values in a correlation matrix, it was in between 0 to 1 only. 0 indicating that no relation, 1 indicating that strong relation, and sometimes it might having the negative values -1 to +1. Okay, so -1 indicating that negatively strongly correlated, +1 indicating that positively strongly correlated. Okay, and 0 indicating that no relation. So here charges which is not much correlated with the children's, there is no correlation among the variables, and moreover no multicollinearity. See, by the time of explanation of assumptions of linear regression, we have multicollinearity, right? Assumptions, whether it is meeting these assumptions or not, we would like to go for check with help of some kind of okay.
Yeah, I think the document you shared yesterday has that one.
This is the thing. Okay, this is logistic regression. I opened the logistic regression, unfortunately. Yeah. Okay, see, we can see that assumptions, no multicollinearity. What is mean that no multicollinearity? The independent variables are not highly correlated with each other. This is no multicollinearity. So how you can able check this assumption? With help of the correlation matrix only, right? The correlation matrix which is solving the many problems and which is giving more information. So here children, body mass index and age, is there any one is related with another one? Is there any positive much relation? Age versus
No.
BMI? No.
Oh,
Age
there
No.
is.
no, right? So that means here children, BIM and age among this are no relation. That means no multicollinearity. Okay.
So I
And
just have a question. So if there's a negative number,
yeah,
then
negative number
even a
indicate
negative,
negative also
even okay,
relation,
negative
having a
correlation
relation.
also we will take consider, right?
Yes, yes.
Okay.
1 and -1 are the correlated correlation values, but the correlation is positive correlated and negatively correlated, which indicating that sign of that one. Okay.
Okay.
And how much it is in the sense, if it is near to 1, then it will be highly correlated. If it is near to 0, it could be no less correlation. -1 in the sense negatively highly correlated. See, and moreover, in assumptions, normality and no independence, linearity. Okay, and your dependent variable, it must be normally distributed. But unfortunately, your data is not normally. Your charges is your dependent variable, right? This dependent variable which is not normally distributed, there could be some kind of skewness is there. Okay, so this is the thing. If you have this kind of data, if you build the linear regression, you won't get the good results. Clear or not? See, if you not transform this data into the normal distribution, then you know what happens here. Even if you build the linear regression model, it won't give you good results. For that one, this is the data set or this is the distribution you should converting into the normal distribution. For that one, we can able to go for using the standard normal distribution or feature scaling. Feature scaling is also not a good idea, but transformation techniques we have it. So here we have a log transformation, log 10. I'm applying the log 10. So when I'm applying the log 10 on your data set, it was converting, this skewed data is converting into the normal distribution. See, here the charges, here also charges only. Here it is a density and here is also density only. But you know what happens here, which is converting normally distributed, but here which is not normally distributed. When your charges or when your dependent variable which is not normally distributed, even if you build the linear regression model, it won't give you the good results. Okay, that's the reason, as assumption of assumption of linear regression, so our dependent variable must be normally distributed. For that one, we should transform your data, otherwise you won't get it. Okay. So keep a look at the left plot. Charges varies 1100 to 3,500. The plot right skewed. The right plot, we will apply the natural log. Then the plot approximately 10 to the normal. Further, for further analysis, we will apply the log on the log on target variable. Why we need to apply the target variable? Why we need to apply the log on the target variable? When your target variable which is not normally distributed, then we should go for apply the transformation. Okay, clear?
So this is for that assumption of normality, right?
This is the assumption of normality with target variable. Normality of residual is different.
Oh, okay.
Normality of residual in the sense, after you predicting the values, after you predicting the model. Okay, so the results of residuals, whether it is normally distributed or not, we need to plot with help of the this kind of histogram disk plot. Okay, with help of the disk plot, we can able to go for we can plot the density plot. When you plot the density plot of residual, then you will be getting the normality line only. Okay, this kind of line only. Okay, but that is different assumption. This is different assumption. This assumption is your target variable should be normally distributed. Meanwhile, the residuals also normally distributed, but residuals you will be getting after you creating the model. But This assumption we should do before we are applying the model. Clear?
Yeah.
Okay, so as of now, I just speak some information regarding about linear regression, and tomorrow we will continue the rest of the things, like what exactly this box plots is doing, and what exactly this villain plots are doing, and data processing steps, and why. And someone is asking question why we are using the pandas. So the pandas important thing is that data cleaning and data handling, data manipulation things. These things we should use it. Okay, and this is the model building. Okay, so I can share with you guys this thing, don't worry about it, but before that one I have to finish it. Okay, pretty cool. And we'll meet tomorrow session for continuation of the linear regression project. Once I done, I can give you some assignment, then you have to work on it. That assignment I will give you on weekend.
Also, would you be able to share that
Yeah, of
multi-linear
course I can share
document
with you. I
and
can share you to
and
documents,
yeah,
project,
and this
everything
Google
I can,
collab?
everything I can share with you.
Thank you. Yeah.
Enjoy the content. Okay. Yep. Thank you guys. Bye. Take care.